Arithmetic. What is the syllabus that comes from the arithmetic topic? It's extremely important for a student to know the syllabus of arithmetic. The kind of questions which I discuss from arithmetic live classes, it will be from a basics to CAT level, CAT advanced level, everything from a basic fundamental onwards. Students who come from a non-mathematic background should be able to solve a CAT level question from a percentage topic. Once you go through all this one, arithmetic, what is the syllabus of arithmetic? What is the syllabus of arithmetic? Most of the examinations, they will have the same syllabus. Depending upon exam to exam, some examinations, like a placement examination, elementary questions are asked. But if I take an SBI bank level examination or a staff selection level of examination, advanced level questions will be asked. But in a CAT level examination, application oriented questions will be there, knowledge based questions will be more, understanding based questions will be more. If you are preparing at a CAT level, automatically any other level examination which will be there. In a Careerville app, you can always join this arithmetic package which is coming out at an affordable price. What is the syllabus? First we will start with percentages. We will start with percentages. Then once we understand the fundamentals of percentages, then we will apply the concepts whatever we learnt in percentages in simple interest based problems. Then we will also apply it in compound interest based problems. We will understand the difference between simple interest and compound interest. We will start at a basic level of compound interest. I will spend a lot of time on advanced level questions in compound interest. Percentages, simple interest, compound interest. Another important application from percentages, that is profit, loss and discount. Profit, loss and discount. Definition of percentages, all the models questions which will come from percentages, simple interest, compound interest and profit, loss and discount. Around close to 20 to 24 hours we will spend time only on percentages and its applications. Percentages, the definition based questions, fundamental based questions, application based question. Once you are comfortable in percentages, you should be able to solve all the problems in simple interest, compound interest, profit, loss and discount. Then we will also solve installment based questions. From percentages topic. This we call it as block 1. Block 1, percentages and its application. Another 20 to 24 hours we will spend time. Similarly, in block 2, we will talk about another important concept, that is ratios. Once we understand ratios, we can solve a lot of problems, from proportion related problems, from an variation related problems, then we can also solve problems related to directly related or inversely related. There is a difference between direct proportion and direct relation. In direct proportion, if A doubles, B also will double. But in directly related, if A increases, B increases, not in the same value. We will do, most of the teachers will not touch upon this concept. Very, very important concept. Proportion, variation, directly related and inversely related. And then we will also solve good number of problems based on partnership. We will solve a good number of questions based on partnership. Proportion, variation, directly related, inversely related and partnership. And another third most important chapter is averages Averages. First we will see the averager on a linear parameter. Then we will solve questions based on mixtures, questions based on weighted average, questions based on alligation, which is the inverse of weighted average. Then we will also solve questions based on removal and replacement. Removal and replacement. Weighted average related questions can be done effectively by using averages. We forgot another important application of ratios. It is ages. Ages also we will solve it here. Most of the ages questions can be solved orally if you have a very good understanding of ratios. The second, this is the block number 3. Block number 3. Block 1, block 2 and block number 3. Block number 3, averages, weighted averages, mixtures, alligations and removal and replacement. In block number 4, the most important block, that is we will discuss based on either based on percentages or based on ratios or based on LCM. We can solve almost all problems in time, speed and distance and time and work. Time, speed and distance and time and work. Once you understand time and work related problems, you can also solve pipes and cisterns based problems. Pipes and cisterns based problems. Pipes and systems. We will also solve problems based on trains. Then we will solve problems based on boats and streams. Boats and streams. Then we will solve problems based on escalators. Escalators. And the seventh one is some very good questions based on miscellaneous problems. Miscellaneous problems. Block 1, block 2. Block 1, block 2, block 3, block 4. This is block 4 and block 5. Block 5. Block 5, which are the new model of questions which are coming from arithmetic. When I say new model of questions, we will solve in block number 5 arithmetic based DI. Arithmetic based DI. It could be time and work based DI. It could be percentage based DI. It could be ratio based DI. It could be mixture based DI. It could be time, speed and distance based DI. And it could also be time and work based DI. Block 1, block 2, block 3, block 4, block 5. Totally, if I take the main chapter as arithmetic, there are 5 important subchapters in arithmetic. The first important chapter is percentages, then its application. Second important chapter is ratios and its application. Third important chapter is averages, mixtures and alligation. Averages, mixture and alligation. Block number 4 is time, speed and distance, time and work. Once you are good in time and work, you can also solve problems related to pipes and cisterns. Block 1, block 2, block 3, block 4 and block 5. On an average, each and every block, we will spend close to 20 to 24 hours. We will spend a lot of time in problem solving. 20 to 24 hours we will spend time. 20 to 24 hours we are going to spend time. We will try to ensure most of the students who are preparing for SSC examination should be writing the examination in the next 3 months. So I will try to complete the syllabus by taking as many classes as possible. From effective from Wednesday onwards, entire March, I will be there with enrolled students maximum, helping them learn the concepts. The biggest priority which I kept next month is to spend a lot of time with the students who are preparing for competitive examination. Last week, I allocated work to all my team members. I have spent a lot of time in the back-end operations. From next week, I should be there in the front end, that is academics. Please make a note of these 5 blocks. The way I am explaining the class, in the same way you should write down in your notebook what are the things that I will tell you, what are the class timings. I hope block 1, block 2, block 3, block 4. Anything that is pending in these 4 blocks, I will put it in 5th block. Once we go through this concept, arithmetic based DI, you should be able to solve it very, very easily. I hope the idea it is clear. 5 blocks, each block close to minimum 20 hours to maximum 24 hours. Percentages. Percentages. What is the first concept which we will discuss? Introduction. We will write down here what are all the concepts that we are going to discuss. Introduction. Product of two parameters equivalent to constant and successive percentage. And successive percentage. These are the 3 things which we will try to cover. See, percent. I will divide it separately. Percent. Per is for. Cent is every 100. Per it is for every 100. If the total value it is given as 100 and I want a part of it, that can be represented as a percentage equivalent to a by 100. A percentage is equivalent to a by 100. Out of 100 parts, total parts how many I want. Out of 100 parts, total part I can give. Right? This could be anything. A by 100. A percentage equivalent to a by 100. A percentage equivalent to a by 100. First important point. A percentage equivalent to a by 100. Always remember, denominator denotes the initial value. Denominator denotes the initial value. Denominator denotes the initial value. What is numerator? That depends upon the question. Denominator denotes the initial value or total parts. Denominator denotes the initial value or it could be total parts. Total parts. Especially in arithmetic problems. In any arithmetic problems, there are 3 ways where you can take a total part. Total part. Either you can take it as 100 percentage or you can take it as 1 or you can take the LCM of the given values. Any question in arithmetic can be solved in these 3 different ways. Total parts can be taken as 100 percentage. If you take 100 percentage, you will get every answer in percentage. If you take total part as 1, you will get every value in fraction. If you take the LCM of the given values, then you will get the answer based upon these constant value. See here, time, speed and distance questions can be solved using percentages. Time, speed and distance questions can be solved using fractions. Time, speed and distance questions can be solved using LCM. Time and work questions can be solved by any of these. Word-based problems. Word-based problems. Here when I wrote ratios, one important thing which in ratios, there could also be an word-based problems where we will convert the English statements into mathematical expressions. There are a lot of questions which are coming from word-based problems. Word-based problems. Even the word-based problems, Anil Nair went to a shop. He purchased 20 pencils or 24 pens. He gave 5 pens to Barun. He gave 2 pencils to Vamshi. Like that, the question could be an English statement, even in an word-based problems. Very, very important. It all depends upon your comfort zone. Some students will use LCM of given values. I would personally use this one in time, speed and distance, time and work. related problems because it helps me to reduce my number of steps. I will always use a method which is very easy for me to understand, which takes less time to compute, and which will have less number of steps. Total part, it will be either 100%. If you are damn good in percentages, use these percentage concept. If you are very good in fractions, use these second method. Entire arithmetic can be solved. Generic methods, 3 methods are there. Method 1, method 2, method 3. These are the generic methods. Which method to choose? It all depends upon your practice, your comfort with a particular topic. Arithmetic, 3 methods are there. So what we'll do is, first method is taking everything in percentage. Second method doing it in fraction. 100% is 100 by 100, which is 1. So what we'll do is, we will understand how to convert percentage into fractions. Wherever some important concepts are there, that we will discuss it. I hope it is clear. A percentage equivalent to A by 100. In my previous class, I told you the difference between value wise percentage and fraction, both are same, but definition wise there is a slightest of the difference, which I mentioned it in the previous class. So a percentage equivalent to A by 100. A percentage equivalent to A by 100. So concept 1. First class will be a fundamental concept. As the class grows, I will increase the level of difficulty. As most of my enrolled students knows that the flow structure to solve this problem is, first is introduction to a concept. I will introduce that concept to you. Then I will discuss some foundation level problems, then foundation level problems, then intermediate level problems, then I will solve advanced problems, then finally I will discuss exam model questions. I will never jump into advanced models without even discussing the first 2. These are I will start with introduction, then I will go to foundation level problems, then intermediate level problems, then advanced level problems. This is the structure. So don't expect me to solve advanced level problems without even solving the intermediate level questions. Today's class, we are going to do introduction to a concept and a foundation level problems. Concept 1. A percentage equivalent to A by 100. A percentage equivalent to A by 100. Now what we are doing is, we are trying to identify how to convert percentage to fractions. How to convert percentage to fractions. Whenever we are doing percentage to fraction based problems, there are 3 different varieties of questions that will come. One is basic high frequency percentages. These are the percentages which are coming very frequently in your examination. Basic high frequency percentages. Then derived percentages. First, derived percentages. The values which are derived from the basic high frequency percentages. Derived percentages. Right? Next one, abnormal percentages, 13.285 percentages. Abnormal percentages, something which takes a lot of time for us to compute the fractions. 13.281 percentage. Suppose if it is 42.8571 percentage, you can directly write it. If it is 9.09 percentage, directly we can write it. Abnormal percentages, if it is given, how to solve it? Abnormal percentages. Then approximation of fractions. Approximated percentages. Then how to use answer options. How to use answer options. How to use answer options. These are the 5 things which we have to make a note. One is basic high frequency percentages. 20% is 1 by 5. 25% is 1 by 4. Derived percentages 34.2857%. We will write some examples here. Example, 20% is a high frequency percentage. 25% is an high frequency percentage. Derived percentage 34.2857%. 36.11%. These are derived percentages. It is a combination of 25% plus 11.11. This is a combination of 25 plus, suppose if I take 20 plus 14.2857%. Abnormal percentage 7.38%. 18.91%. 18.91%. How to approximate values of 361 by 631, 123 by 487, 37 by 73. How to approximate percentages? Use the answer options. When to use the answer options? When to use the answer option? When the denominator digital sum is 2, denominator digital sum is 4, it is 7, and it is 8, and it is 5. How, when to use answer options? If the questions are in fractions and if the denominator digital sum is 2, denominator digital sum is 4, denominator digital sum is 7, denominator digital sum is 8, 5 and 1. 5 and 1. We can use exact answer options. Only when the denominator digital sums are 1, 2, 4, 5, 7 and 8, then only we can make use of answer option. Question contains fractions, answer contains answer options. Digital sum 1, 2, 5, 7 or 8, right? And if the answer options are approximated, then also digital sum cannot be used if the answer options are approximated. Please write down in the same structure whatever I am telling you. Most of the teachers will teach 1, 2. So we will go with a particular structure. We will understand this value and we will solve some problems. This value and we will solve some problems. This and some problems. This and some problems. How to use answer options? That also we will solve. I hope it is clear. Any student who is not able to see this live class on Careerville app, I will definitely speak to the Careerville time. I expected that this technical issue may happen. That is the reason I am playing the class live on Anil Nair classes YouTube channel. I will speak to the team. Thank you, Sushil, for updating me. Right? Now, if you see here, basic high frequency, derived percentage, abnormal percentages, approximation percentages, and use answer option. What do you mean by abnormal percentages? Percentages which cannot be converted into fractions from either derived concept or from the base concept. 18.91%, 23.47%. Very, very interesting. We will go very slowly, very steadily. We will solve as many problems as possible so that right after this week is over, percentage related, you are damn good. Introduction, foundation, intermediate, advanced and an exam model. Use answer option. If the denominator digital sum is 2, how to use answer option? Multiply the numerator and denominator by 5. Please write down that concept. Multiply the numerator and denominator by 5. If it is 4, by 7. If it is 7, by 4. If it is 8, by 8. If it is by 5, 2. Idea is to make the denominator digital sum as 1. Idea is to make the denominator digital sum as 1. 2 5s are 10, digital sum 1. 4 7s are 28, digital sum 1. 7 4s are 28, 2 plus I, digital sum 1. 5 8s are 40, 5 2s are 8 8s are 64. These 8 is for the 8. 8 8s are 64. 1. 5 2s are 10. 10 digital sum is 1. So these are the 5 concepts which we are going to discuss. It's very, very important for us to know the equivalent fraction for a percentage. Sometimes you can find out, sometimes you cannot find it out. If you cannot find it out and the answer options are there, where all the answer options are exact, then we can use the answer option approach. If the answer options are approximated, how to find out the approximated? These are the 5 flavors or 5 varieties of questions that can come from the percentage introduction. Now let us attack with basic high frequency percentages. Basic high frequency percentages. A percentage is called as A by 100. A percentage is called as A by 100. Left side I will write fraction. Right side I will write percentage. Very, very basics onwards will start. Left side fraction and right side percentage. Listen carefully, sir. Fraction, if it is 1 is nothing but complete. Complete, it is given by 100 out of 100. 100 percentage. 1 is 100 percentage. When I say 1 by 2, 1 by 2. 1 by 2. What does that mean? 1 by 2. It's very important for us to understand the definition of a fraction. 1 by 2. Out of total 2 parts. Out of total 2 parts. Out of total 2 parts. I need 1 part. Out of 2 parts, I need 1 part. It is in fraction. But in percentage, the total parts are, the denominator always denotes the initial value. For 100 parts, how much I require? So this will become 50. So this will become 50 by 100. 50 by 100. By 100 can be replaced by the symbol 50 percentage. Can be replaced by the symbol 50 percentage. 1 by 2. Denominator in the fraction it is 2. But according to the percentage, denominator should be 100. So 2 50s are 100. 150s are 50. 50 by 100. Out of 100 parts, I want only 50 parts. Out of 100 parts, I want 50 parts. So that is the symbolic representation will be 50 percentage. Next is 2 by 2. 2 by 2 it is 1. Next is 1 by 3. 1 by 3. Now if you see here 1 by 3. How many times 3 goes in 100? How many times 3 goes in 100? 100. Factors are 2 and 5. 100 is 2 square into 5 square. 100 is 2 square into 5 square. So 3 will not go in 100. So I am getting an approximated value or the most closest value. 33.33 percentage. Most closest value, which is 33.33 percentage. You should go to Google and refer why 0.999999. 0.9 bar, they will make it into most closest as 1. Most closest as 1. So 1 by 3, 33.33 bar. Anyway, there are another 6-hour session that is pending on fractions and decimals. That also we will try to cover it up. 1 by 3, it can be written as 33.33 percentage. From here onwards, whenever 33.33 percentage is there, most closest fraction will be 1 by 3. 2 by 3, 2 times 1 by 3. 2 by 3, 2 times 1 by 3. 2 times 33.33, which will be 66.66. Most closest. 3 by 3 it is 1. 3 by 3 it is 1. 1 by 4. 1 by 4. Whenever somebody says 1 by 4, you should immediately say, out of 4 parts, I require 1 part. But in percentage, total parts are 100. 4 25s are 100. 125s are 25. 25 on 100. So it is 25 percentage. 1 by 4 is 25 percentage. Why 1 by 4 is 25 percentage? Out of 4 parts, I require 1 part. Out of 4 parts, I require 1 part. But I want in 100 parts. 125s are 25. 25 by 100 is 25 percentage. 2 by 4 is 1 by 2. 3 by 4 is 3 times 25, which is 75 percentage. 1 by 4 is 25 percentage. 3 by 4 is 75 percentage. Elementary class, foundation class, so that when we are doing an SSC CGL or a CAT level questions, you will not find it difficult. Next one, 4 by 4 is 1. Next it is a fraction. And this one is a percentage. 1 by 5. 1 by 5. Out of 5 parts, I require 1 part. Out of 5 parts, I require 1 part. But according to percentage, I require 100 parts. 520s are. So 20 by 100. 20 on 100, which is 20 percentage. 2 by 5. It is 2 times 1 by 5. 2 times 20. 3 times 20, which is 60. 4 times 20, which is 80. 5 times 5, 5 by 5 it is 1. 1 means total it is given by 100 percentage. Again I am repeating, in all arithmetic problems, 100 percentage I can take if the total value it is there, or 1 I can take, or the LCM of the given values I can take. 1 by 5. I hope the idea it is clear. Next one, fraction and percentage. 1 by 5, it is over. Next is 1 by 6. 1 by 6. 1 by 6 is 1 by 2 into 1 by 3. 6 goes how many times in 100? 6 16s are 96. 6 17s are 102. 6 will not go. So I am getting the most closest answer. Most answer. So this can be written as 1 by 2 into 1 by 3. 1 by 2 into 1 by 3. 1 by 2 it is 50 percentage divided by 3. So most closest will be 16.67 percentage. 16.67 percentage. Please see the denominator here. Denominator is 6. 6 is a combination of which all prime numbers? 2 and 3. If the denominator it is a combination of 2 or 5, or only 2, only 5, or 2 or 5, then I will get the exact value. Otherwise, I will get the most closest answer. Again, I am repeating it. I will write down the point here. If the denominator, very, very good point, sir. If the denominator is derived from either only power of 2 or only power of 5, only power of 2 or power of 5 or powers of 2 and 5 or powers of 2 and 5 or powers of 2 and 5, I will get exact values. Else I will get approximated values. Please make a note of it, sir. Make a note of it. So 33.33, it is the most closest answer for 1 by 3. It is the most closest answer for 1 by 3. If the denominator is derived from either power of 2 or power of 5 or powers of 2 and 5, then only I will get the exact values. Underline these keywords, sir. Then only I will get the exact values. Else I will get the approximated values. Denominator it is 5. 5 is 5 power 1. These are all the exact values. 6 is derived from 2 and 3. denominator contains a multiple of 3. So this is an most closest answer. Which one of the following? You will definitely get confused whenever you are solving a calculation based DI problems. Sir, here I am applying this concept, it is not working. It could not be working because of this concept. Very, very important concept, sir. Very, very important concept. That is the reason here I can write equivalent to. Here I wrote very carefully most closest answer. Denominator, if the denominator is a numerical value which is derived from only power of 2 or only power of 5 or powers of 2 and 5, then I will get the most closest answer, else I will get the approximated answer. If anybody writing it is equivalent to, it is a mathematical mistake. Most closest, it is most closest. What is the next value? 2 by 6. 2 by 6 is 1 by 3. Already we did. 3 by 6 is 1 by 2, which we already did it. 4 by 6 is 2 by 3. Already we did it. 5 by 6. 5 by 6 can be written as 1 minus 1 by 6. 1 minus 1 by 6. 1 is 100 percentage. 1 by 6 is 16.67 percentage, which is equivalent to most closest value 83.33 percentage. Most closest value. Answer is 83.33 percentage. Very, very careful with these symbols. Very, very careful. 5 by 6. 83.33 percentage. Some teachers who do not have a great understanding of mathematics, they will probably, what they will do is, they will say, convert division into multiplication to use a digital sum. Digital sum cannot be used here. If I see here, 5 by 6 is 83.33 by 100. Those people who write equivalent to, where it is matching 3 plus 3, 6, 6 plus 3, 9. 9 plus 8, 17. 17 it is 8. 8 6 are 48. 4 plus 8, 12. 1 plus 2, 3. 5 into 1, 5. 3 is not equivalent to 5. How come it will be equivalent to? 5 by 6. 6. Most closest it is 83.33 percentage. 83.33 percentage, nearest fraction will be 5 by 6. Especially when the denominator is derived from any number other than 2 and 5. Please do not cross multiply and apply digital sum. I am sure each and every key point, whatever I am specifying, I am sure you are writing down in your notebook. This will be extremely important to you to eliminate some incorrect answer options, or in hurry you will do this mistake. One mistake will affect a lot of your chances of getting into your dream destination. I hope it is clear. Any clarity missing? Again I am repeating it. In a fraction, denominator always denotes the initial value. Sir, what is the numerator? It depends upon the question. When I am discussing that increase, decrease, I will come back to that one. Whenever there is a fraction, denominator denotes the initial value. 1 by 5. Denominator it is 5. That means total 5 parts are there. But I want 100 parts. 5 20s are 100 and 120s are 20. How we are converting fraction into percentage? Why? Fraction to percentage, we have to multiply by 100. Most of them do not know. They blindly multiply by 100. Why we are multiplying by 100? 5 20s are 100. So 120s are 20. Out of 100 parts, I require 20 parts. So symbolic representation will be 20 percentage. This slide is very, very important to me. It is explaining a concept. Cross multiplication of denominator with the answer. Converting division into multiplication will not always give a digital sum same if the values are most closest. Exact, you might get the answer. Next slide, extremely important slide, sir. Very, very important slide. Very, very important fraction. Extremely important fraction. Very, very important fraction. that is 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7. Listen carefully, sir. 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7. These are the various fractions. We have to convert it into a percentage. We have to convert it into a percentage. Please write down a note. Write down a note. If P is a prime number, if P is a prime number, if P is a prime number not equivalent to 2, 3, 5. If P is a prime number not equivalent to 2, 3, 5. 1 by P, it is a recurring decimal. 1 by P, it is a recurring decimal with a cyclicity of factor of P minus 1. Very, very important concept. With a cyclicity of factor of P minus 1. If P is a prime number, P not equivalent to 2, 3, 5, then 1 by P, it is a recurring decimal with a cyclicity of factor of P minus 1. What is the proof behind this concept? Proof behind this concept is derived from Fermat's little theorem. Fermat's little theorem. What is the idea? From where this concept is derived? It is derived from the Fermat's little theorem, which goes like this. A power P minus 1 by P equivalent to 1. A and P are co-prime. A and P are co-prime and P is a prime number. P is a prime number. From these Fermat's little theorem, this concept it is there. Now, see here, sir. The student who want to know the proof behind this concept, you can always go and download this book, Hall and Knight Algebra book. Hall and Knight Algebra book. I took this concept from this book, Hall and Knight by Algebra. Hall and Knight by Algebra. Now, there are a lot of doubts a students might get. P is a prime number not equivalent to 2, 3 and 5. Here it is a single prime number. What it is? P power k. What if it is P1 into P2? Are you all with me? P1 into P2. Everything. That is something which we are going to discuss in fractions and decimals. Right now I will focus only on P power 1. It could be P power k. It could be 1 by 49. Am I right? It could be 1 by 15. It could be 1 by 35. It could be a combination of multiple prime numbers. That concept we will discuss it in fractions and decimals. Only we are concentrating on singular prime numbers in the denominator. If it is a combination of prime numbers, there is a concept that we will discuss. If it is P1 power k, then the cyclicity will be P1 power k into 1 minus 1 by P1. If it is P1 into P2, then we will take the LCM. That in this detail, that is a special 2 hours class that is dedicated to recurring and terminating decimals, that I will park it for some time. Now see here, if P is a prime number not equivalent to 2, 3 and 5, there is a reason why it is not equivalent to 2 and 5. If it is 2 and 5, then it will give a terminating decimal. It will give a terminating decimal. 1 by 2 into 100, it is a terminating decimal. Why? Because 100 prime factors are 2 and 5. The 100 can be written as 2 square into 5 square. So if the denominator it is 2 and 5, I will get a terminating. If it is 3, if you see here, I will tell you for 3 also. Why? Because I want my students to have a crystal clear clarity, sir. 10 square divided by 3, it is equivalent to 1. Am I right? A and P are co-prime. 10 and 3 are co-prime. Denominator, it is a prime number. 3 is a prime number. 100 divided by 3. 100 divided by 3. It is 3. 33s are 99, remainder 1. So this can be written as 10 square minus 1 divided by 3. 10 square by 3, it is 1. 1 minus 1, it is 0. 100 minus 1 is 99. 99 can be written as 9 into 11 divided by 3. 9 is perfectly divisible by 3. 9 is perfectly divisible by 3. 9 is perfectly divisible by 3. So that is the reason P is not equivalent to 3. Even if you take 10 power 6 by 7 equivalent to 1, this will become 10 power 6 by 9 into 6 ones divided by 7, it is 0. 9 is not divisible by 7. So this should be divisible by 7. If it is 7, this is written 6 times. It is written 6 times. That is the reason I am getting a factor of P minus 1. Very, very important concept. Blindly mugging the fraction to percentage will take you nowhere. You are 10 years behind the current questions that are asked if somebody is just telling you how to convert fraction into percentage without giving you the concept behind that one. If P is a prime number not equivalent to 2, 3 and 5, it will not be equivalent to 2 and 5. Why? Because it will result in a terminating decimal. It will not be equivalent to 3. Why? Because 9 into something. 9 is divisible by 3. 9 is divisible by 3. Sir, how come you got P minus 1? Because 10 power 6 minus 1 can be written as 6 nines, 9 common, 6 ones. So if it is 7 times, I got 6 ones. If it is 13 times, I will get 12 ones. So that is the reason it is P minus 1. Why it is a factor of P minus 1? If 10 power 6 by 7 is 1, 10 cube by 7 can give you plus 1 or minus 1. A square equivalent to 1. A can give you sometimes plus 1 or A can give minus 1. There is a chance for A to become 1 for A square equivalent to 1. So that factor also can be a chance. That factor also can be a chance. Each and every statement, I hope it is clear. Previous statement, denominator it is only 2 or 5. It is terminating decimal. That is the reason 2 and 5. 3 it is out here. That is the reason 2, 3 and 5. It will result in a recurring decimal. Factor of P minus 1. Because of that, formats a little theorem. Especially after listening to my class, if you are explaining this concept to somebody, you should say it with an authority and a confidence so that a student will actually understand how these percentages are derived. Otherwise, R.S. Agarwal book is required for you to mug it up, right? My role is to give you a concept beyond what is said in the textbook. 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7. What is the denominator? 7. If it is 7, the digits will be repeated. That is the definition of recurring with factor of P minus 1. So what is 7 minus 1? 6. This will get repeated either in 6 or the factors of 6. Let us do it. 1 by 7. 7 will not go an exact factor of 100. So multiply by 100. If I multiply by 100 and divide it, I will get most closest. Again, this keyword is very, very important, sir. It is not the exact answer. Denominator other than 2 and 5, we will never get an exact. Very, very close. 1 by 7 is 14.2857. How you got 14.2857? 100 I divided. 7 14s are 98. 20. 7 2s are 14 and so on. I hope it is clear. 14.2857. Very, very interesting concept. Listen, sir. 142857. How many digits we got? 6 digits we got. According to this concept, it should have a cyclicity of these 6. Cyclicity. That means these 6 digits only will get repeated. Are you all with me? These 6 digits only gets repeated. How these 6 digits get repeated? Let us see. 2 by 7. Multiply these numerator by 10. Just hypothetically assume. What is 2 tens are 20. 7 goes how many times in 20? Please tell me. 7 goes how many times in 20? 7 2s are 14. 7 3s are 21. Minimum how many times it is going? 2 times. Where is the digit here? 2. Write down these digit and the next digit. Dot the remaining digits in serial order. 28.5714. Again I am repeating. Denominator it is 7. So the percentage number of digits will be a cyclicity of factor of 6. Factor of 6 means it could be 6, 3, 2 or 1. 3 digits it is not repeating, 2 digits it is not repeating, single digit it is not repeating. So definitely 6 digits it should repeat. These 6 digits only should come in all these values. But how to find out the values? 2 by 7. Take the numerator 2, multiply by 10. What is 2 tens are 20. 7 goes how many times in 20? Minimum value. 7 twos are 14. 7 threes are 21. Minimum 2 times it will go. So 28.5714. 3 by 7. Take the numerator 3, multiply by 10. 3 tens are 30. 7 goes how many times in 30? 7 fours are 28. 7 fives are 35. 4 times it will go. So answer will be, write down this digit and the remaining digit in serial order. 42.8571. I hope you are all there with me. Why these 6 digits are only getting repeated? It is an absolute nonsense if you just mug up these values. If I give you application based questions, you will not be able to solve because all you know is just mugging up this concept. There is a difference between my way of teaching and another traditional teacher's way of teaching. I tell the concept, I give the proof behind the concept, and I tell the application of the concept. 4 by 7. Take the numerator 4, multiply by 10. 4 tens are 40. 7 goes how many times? 5 times. 57.1428. 57.1428. I hope the idea it is clear. Next one, 5 by 7. 5 by 7. 5 tens are 50. 7 goes how many times? Just to make our life easy, I am just taking the numerator by 100. Instead of finding the first 2 digits, I am finding the first digits. Ideally, I should multiply 2 with 100. 200 by 7, it is a little complicated. 5 tens are 50. 7 goes 7 times. 71.4285. 71.4285. 6 by 7. 6 tens are 60. 7 eights are 56. 7 nines are 63. 8 times it will go. So it is 85.7142. 85.7142. Please put a star mark on this concept. Very, very important concept. Extremely important concept. What are the learnings from this slide? First of all, if the denominator it is any prime number other than 2 and 5, I will always get the most closest answer. That is learning point number 1. Point number 2, if the denominator is a prime number other than 2, 3 and 5, 1 by p will always give a recurring decimal. The digits will get repeated with a factor of p minus 1. From where it is derived? Fermat's little theorem. So 1 by 7, if I just take 1 by 7 multiply by 100, 14.2857. Denominator it is 7. That 6 digits should get repeated. They are only repeating. If you observe all these values, they are only repeating. 2 by 7. 2 tens are 20. 7 goes 2 times. 7 goes 2 times. 28.5714. Are you all with me? 3 tens are 30. 7 goes 4 times. Are you all with me? Idea it is clear. 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7. 6 by 7. Idea it is clear. Based upon these, a CAT question can be developed. A question is like this. There is a 6-digit number. 1 A, B, C, D. It is multiplied by 3. It is A, B, C, D, E, 1. Find A value, find B value, find C value, find D value, and find E value. There is a 6-digit number with the leftmost one. That 6-digit number is multiplied by 3. If a 6-digit number is multiplied by 3, leftmost one became a rightmost one. Leftmost one became a rightmost one. Decode these variables or find out the variables equivalent numerical values. 1 A, B, C, D, E into 3, it is A, B, C, D, E ending with 1. So we will solve it in two methods. Traditional method. Traditional method. Traditional method. How most of the students will solve this problem? See here, sir. 1 A, B, C, D, E into 3. It is A, B, C, D, E ending with 1. Ending with 1. So now please see here, sir. How students will solve? E is multiplied by 3. E is a digit. That digit is multiplied by 3. I got 1. E multiplied by 3. Listen carefully, sir. E multiplied by 3. I got 1 at the end. E multiplied by 3. I got 1 at the end. E is a digit. Can the digit be 0? No. 0 3s are 0. Not possible. It is 1. So E cannot take 0, it cannot take 2, it cannot take 4, it cannot take 6, it cannot take 8, it cannot take, because even into any number, even number I will get. The answer unit digit, it is an odd number. So D is an odd number, E should be an odd number. So it has to be an odd digit. It has to be an odd digit. It cannot take 5, because any number multiplied by 5, unit digit will be 0 or 5. 0, 2, 4, 6, 5 out, not possible. So what are the cases possible? 1, 3, 7, 9 possible. 1 3s are 3. I need unit digit 1. Not possible. 3 3s are 9. It is not possible. 9 3s are 27. 7 not possible. So 7 it is possible. Step number 1, we decoded E value to be 7. Step number 1, we decoded E value to be 7. Are you all with me? E value is decoded as 7. First, step 1, it is clear to me. Step 2. Step 2. Lengthy process. So this E value is decoded as 7. E value is decoded as 7. 7 3s are 21. 1, 2 carried. So the next is 3 into D plus 2 is equivalent to E, which is 7. 3D plus 2 equivalent to 7. D if I take 1, 3 plus 2, 5. D if I take 2, 6 plus 2, 8. D if I take 3, 3 3s are 9, 9 plus 2, 11, 1. D if I take 4, 12 plus 2, 14. D if it is 5, here it is 5. 3 5s are 15, 15 plus 2, 17. So D value it is 5. Again, step number 3. See how complicated it is becoming. So this can be written as 1 ABC 5 7 into 3. This is 7 and this will become 7. Next we have to find out ABC 5. Like that you have to go. Step 1 will give you E. Step 2 will give you D. Step C will give you C. Then B, then A. Like that you have to move from right to left and you have to find the values of A, B, C, D. Almost it will take minimum 2 to maximum 4 minutes to solve this question. Minimum 2 to maximum 4 minutes it will take to solve this question. This question is a CAT level question. We will not use this concept. This is a CAT level question. Now Anil Nair's approach. If I see this question, how I solved this question is Anil Nair's approach. Immediately it has given an idea. What is 1 by 7 actually? What is 1 by 7? Now if you observe the question, there is a 6-digit number. the same 6-digit number is coming in the answer. The same 6-digit number is coming in the answer. Same 6-digit number. That means the same 6-digit it is coming. Only the shift in the order in which the digits are there. Just now we discussed if 6 digits will get rotated in 1 by 7. 1 by 7 is 14.2857. It is multiplied by 3. 3 by 7 is 42.8571. 1 by 7 it is multiplied by 3, and these answer is leftmost one became a rightmost one. Leftmost one became a rightmost one. Remaining is as it is. Leftmost one became a rightmost one. I hope it is clear. Leftmost one became a rightmost one. Remaining as it is. Remaining as it is. So the number is nothing but just a 20 seconds problem. 142857 into 3. Answer is 428571. 428571. This is the beauty of knowing the concept. If the denominator it is 7, then the answer will be a recurring decimal with the number of digits, either a factor of p minus 1. Here it is p minus 1. So 1 by 7. What is very keen observation to the question, you will get the answer. There is a 6-digit number. There is a 6-digit number. The same 6 digits are coming in the answer option. The same 6 digits are coming in the answer option. Leftmost one became a rightmost one. Leftmost one became a rightmost one. So that is the reason I used 1 by 7 as 14.2857 multiplied by 3. Just now we discussed the logic. 3 times 14, 3 times. So 7 4s are 28, 20. Write down this digit and the next digit. Dot the remaining digits in the serial order. Dot the remaining digits in the serial order. Toughest CAT question can be solved in seconds if you keep listening to my classes. Each and every slide will teach you something. There will be no memory based questions. There will be no straightforward solution key based problems. I have a habit of creating questions on the spot. I have a habit of changing the questions on the spot and telling you what will happen if the question changes, so that you probably become more of a question setter than the examination giver. I want you to learn from an person who creates questions rather than just a substitute to the solution key. I hope the idea it is clear. One concept and an application based question. Every class of arithmetic I am going to solve like this. Every week 15 hours massive content we are going to discuss. Give me 6 to 7 weeks of time, I will make you damn good in arithmetic. I will make you damn good in arithmetic. I hope the idea it is clear. 1 by 7 over. Next one, 1 by 8. 2 by 8 is 1 by 4. 3 by 8. 4 by 8 is 1 by 2. Next is 5 by 8. 6 by 8 is 3 by 4. Already we did. Next is 7 by 8. Next is 7 by 8. 1 by 8, 3 by 8, 5 by 8, 7 by 8. I removed a few values because which we already did. Now if you see here, 8 is nothing but a power of 2. So all the answers will be the exact answer options. Exact answer option. 1 by 2 into 1 by 4. 1 by 4 is 25% by 2, which is 12.5%. Exact answer options. 3 by 8 is 3 times 1 by 8. 3 times 12.5, which is 37.5. 5 by 8. 5 times 1 by 8, which is 5 into 12.5. 62.5%. 62.5%. 6 by 8 is 3 by 4. 7 by 8 is 7 times 12.5, which is 87.5%. Which is 87.5%. I hope the idea it is clear. I hope the idea it is clear, right? Next one. 7 by 8. 7 into 12.5%, which is 87. 0.5 percentage. Now see here, sir. Because it is closest, 7 by 8 is 87.5 by 100. Cross multiply 7 into 1 and left hand side digital sum, it is 7. Right hand side 8 plus 7 15, 15 plus 5 20, 20 digital sum is 2. 2 8s are 16. Left hand side digital sum equivalent to right hand side digital sum. Left hand side digital sum is equivalent to right hand side digital sum. 5 plus 2 7, 7 plus 1 8, 8 8s are 64. 64 digital sum is 1. I hope the idea it is clear. 7 plus 3 10, 10 plus 5 15, 15, 6 8s are 48, 4 plus 8 12, 1 plus 2 3. Crystal clear concept. Next one, it is 1 by 9, 2 by 9, 3 by 9, and so on up to 8 by 9. 8 by 9. Now listen carefully, sir. 1 by 9, 3 by 9, 1 by 9, 2 by 9, 3 by 9, and so on up to 8 by 9. I will also write 1 by 11. Next is 2 by 11. Next is 3 by 11. And so on up to 10 by 11. And so on up to 10 by 11. And so on up to 10 by 11. Now listen carefully. I will correlate with the denominator 9 and 11. Case 1. Denominator, it is 9. 9 is 3 square. Till now we discussed only a singular prime number. Only a singular prime number. It is the square of a prime number. Case number 2. Denominator, it is 11. 11. That means answer recurring decimal will be a factor of 11 minus 1, 10. Factor of 10 is 1, 2, 5, 10. These are the factors of 10. 1, 2, 5 are 10. Are you all with me? Factors of 10 are 1, 2, 5 and 10. Now see here. If it is 9, if it is 9 square, so cyclicity will be factor of P1 power K into 1 minus 1 by P1. From where it is derived, once I discuss fractions and decimals, I will tell you. These are 9 into 1 minus 1 by 3, which is 2 by 3. So 3 2s are 6. What are the factors of 6? 1, 2, 3 and 6. Take the HCF of these both. Take the HCF of these both. 1 is common, 2 is common. What is HCF? 2. That means answer will be a recurring decimal with a periodicity of 2. Both the fractions will have recurring decimal. Answer, the digits will be repeated after 2 steps. What is the periodicity of? In what way 9 and 11 are connected to each other? Now see here. This is how we are going to connect the dots. Denominator, it is 9. 9 is a composite number. Composite number can be written as 3 square. So, in what will be the periodicity? Anyway, 9 is not a power of 2 and 5. So, answer number of digits will be repeated. In what way, in what pattern the number of digits will be repeated? 9 into 2 by 3, it is 6. So, answer will be a factor of 6. Either the 6 digits will be repeated, or 3 digits will be repeated, or 2 digits will be repeated. Right, similarly, if it is 11, 11 means answer number of digits will be repeated in the factor of 11 minus 1, 10. 1, 2, 5, 10. What is common in both of them? HCF, it is 2. So, both of them number of digits will be repeated after 2 steps. What are the 2 steps? 9 is not factor of 100. So, approximating it is 11.11 percentage. 11.11 percentage. 99.9999 percentage is equivalent to closest answer. These are all closest values. By this time, you should have understood the difference between the most closest and the exact. 11.11. Sir, if you observe, how many digits will be repeated? 11 will be repeated twice. 2 by 9. 2 times 11. 22.22. 3 times 11, 33.33. 4 times 11, 44.44. 8 times 11, 88.88%. 88.88%. Number of digits repeated will be 2. 11. 11 will be number of digits repeated will be 2. Am I right? 11 nines are 19, 9. 2 times 9, 18.18. Number of digits repeated are 2. 3 times 9, 27.27. 4 times 9, 36.36. 10 times 9, it is 90.90. I hope you are able to identify how am I connecting the dots when the denominator it is 9 or 11. Denominator it is 9 and denominator it is 11. Number of digits repeated in both of them, it is 2. So 9 11s are, 9 is not a factor of 100. So the most closest will be 11.11. 2 times 11 is 22.22. Or in case if you want to remember it, remember 9 by 11, Old Trade Center collapse. Old Trade Center collapse. 9 by 11, World Trade Center collapse. If the denominator it is 9, multiply the numerator by 11. If the denominator it is 11, multiply the numerator by 9. If the denominator it is 9, multiply the numerator by 11. If the denominator it is 11, multiply the numerator by 9. I hope this idea it is clear. 1 by 9, 2 by 9 till 8 by 9, 1 by 11, 2 by 11 and so on up to 10 by 11 and so on up to 10 by 11. I hope the idea it is clear. I hope the idea it is clear.